Hi, this is Chandrakala. Have you ever tried to debug Java issues in Docker containers? How does one go about doing this? This demo talks about one mechanism in which OpenJ9 that makes it a lot easier to obtain debug information from Java applications running inside Docker containers. In this demo, I'll demonstrate how to use the newly added OpenJ9DiagnosticsMXBean to dynamically configure the dump options for a containerized application running in the cloud environment. For this demo, I've used a Kubernetes-based cloud such as the ICP, IBM Cloud Private, and I've created a Docker image of the application. The application is a simple Hello World servlet, and I've created a Docker image using the Hello World servlet along with the Liberty package and the adopt OpenJDK8 OpenJ9 nightly build, which contains this MXBean. And I've pushed it onto the Docker Hub. Now we will look at how to deploy this application onto the ICP. So we will need a Linux machine. I've installed kubectl here. We will basically be using the kubectl commands to deploy applications to the Kubernetes cloud. Before deploying, let us review the YAML file which I've used for the deployment. This is the YAML file. In the YAML file, we have specified an NFS server as a persistent volume, which is mounted again in the container at this mount path. So any dumps which we trigger will be stored here on the NFS server. And we've also mentioned the Docker image. The Docker image will be pulled from Hub Docker here. Now let us deploy this application. So we had two services. We had a deployment and service. Both have been created. Let us check if the application has been deployed using the kubectl get pod. This is the pod that has been created and it is running. We can check the application logs by using the kubectl logs command. We will need to pass the container name. This is the container name that I have specified in the YAML, and this is the pod name. Yeah, so these are the logs. So from the logs, we can see the Hello World servlet has been started. Now we can use the JConsole on the Windows machine to monitor this application. Let me launch the JConsole. This is the JConsole UI. We need to enter the service JMX URL here. I've already kept it ready. So the IP address and the port number is the node port and the service, the IP address where the service has been deployed. Let us copy paste that here and enter the username and password that we've configured for the application. Now let us go to the MBean tab. Under this MBean tab, you will see the OpenJ9 Land Management, which contains the OpenJ9DiagnosticsMXBean. So it has these various operations and dump options. Dump options is the one which we can use to dynamically configure the dump option. Let us now request a heap dump on allocation of 1 KB object. So this is the setting. The option is the same as that we passed through the -xdump command line option. So we are basically requesting a heap on the event allocation, and the size given is 1 KB. And we've also specified the file, and /varlog, as we saw, is the mount path, so that the heap dump gets created on the persistent storage that is on the NFS server. Let's copy paste this here. Going back to the Linux console, we can see that it has dumped this. So here in our simple Hello World servlet, we have simulated the allocation of 1 KB object. So that is the reason on occurrence of that event the heap dump has occurred. Let us go to the NFS share volume. We can see the file here. The dump has got created. Let us now try another dump option where we want to trigger a Java dump on the event thread start. Again, okay, let us go to the console. Yeah, so the Java dump has been generated and it is stored here on the NFS server. Now let us look at the other options. What we have trigger dump to file and trigger a classic heap dump. Let us use trigger dump to file here. We can specify any of the supported dump agents. Let us create a snap trace. So we can see that the snap dump has been written to the NFS storage. Trigger classic heap dump is for triggering a classic heap dump in the classic format. You can use the other trigger dump options too. Where triggering a Java dump, it writes to the default location that is on the Virtual Liberty server, default server location. We can also reset all the dump options that we've configured by using the reset dump options operation. Before resetting, let us look at what are the dump settings. In the dump settings, we can see the events or the dump settings that we recently added using the JConsole, the heap and allocation event. Let's go to the JConsole and click on the reset dump options. And we can again view the settings. This should have been reset now. So those settings that we configured using the JConsole have been removed now, and it has gone back to what it was at JVM initialization. So that is all I had. If you have any questions, you can post it on the OpenJ9 Slack channel, or you can report any problems using the OpenJ9 GitHub project. The links are here. And thanks for watching this video.